Today we're going to look at projections. Specifically, we're going to look at the projection of the line x equals 2, which I've already drawn in, to the line y equals -4, just for this example, and then we'll come up with a generic case later. So we're going to choose random points that is going to project to the line from x equals 2 to y equals -4. So I'm just going to choose one line here, which is just the basic where the y equals 2, y equals -4, and x equals 2 cross. So that's that point. Then we're going to take a look at the point 2, 2, and where it reflects onto the y equals -4 line. This is going to be right here. And this point is somewhere that we can't tell right now. So when we look at this, we see this slope. We know that for our y equals -4 line, we're going to have some x prime value that's manipulated somehow from the x equals 2 line, and we're always going to have -4 here. Because this x equals 2 line always has the value of x, or 2, we're going to look at what the y does to influence this x prime. So we're going to basically look at the slopes and compare them together. So from our I at 0, 0, we're going to find the slope of the x equals 2 line. So as you know, slope is rise over run, y minus 0 over 2 minus 0, you get y over 2. Again, we're going to do the same thing from our I to any point on our y equals -4 line. We're going to get -4 minus 0 over x prime minus 0. We get -4 minus over x prime. As you can see, we've got the two slopes for the lines. This slope is any generic point 2 y equals -4, and the y over 2 is any slope to x equals 2. When we put them together, we want to compare them. Y equals 2 is equal to -4 over x prime. Let's cross multiply to get x prime y is equal to -8. What we're going to do is we want to get some point influenced by x, or y to influence x prime. So x prime is now equal to -8 over y. That is what's going to influence our line here. However, as you can see in this slope, that the x prime is on the bottom, so x prime cannot equal 0. So when we wanted to take a look at this point, it would be influenced by this y value here. So our x value, this point is x prime 1, -4. So our x prime 1 is equal to -8 over the y value of the x equals 2, which is 2. So here our x prime 1 is equal to -4. So this point here is -4, -4. As you could tell, as you could see, as we get any of our y values on the x equals 2 line, we'll get any value off to infinity on the y equals -4 line, as well as onto the, I'm sorry, I'm projecting incorrectly. So any point you choose on x equals 2, once you get closer and closer to where the points meet from the I, you see that this projection goes off to infinity. However, once you hit this 0 slope here, this 0 slope, x prime cannot exist because x prime is not reflected any or projected anywhere onto the y equals -4 line. So you'll never see any projection when the slope is like this. However, when you move past going this way, you'll again start hitting the line y equals -4, projection onto that line. So when you think about it, you want to find some generic case for this. So the generic case for any projection from x equals 2 onto any perpendicular line to it, let's choose a different line just so we can see this. We're going to choose y equals 2 now. Okay. So again, you have your x prime value, and now your y's are always 2, and of course your 2y for your x equals 2 line. You're still going to have that y over 2 slope, but for the x prime, you're going to have 2 over x prime. When you look at this, or when you compare them, you have y over 2 is equal to 2 over x prime. Again, x prime cannot equal 0. So you have x prime y is equal to 4, so x prime is now equal to 4 over y. So if you want to look at the projection for when you have the point 2, 4 onto your y equals 2 line, use your formula x prime 4 over y, so your x prime is 4 over y, your y value here is 4, so your x prime is now 4 over 4, which is 1, so your new point on this line is 1, 2. If we come up with a generic case for this, we can say, based on this, when you say x prime is equal to 4y or negative 8y, you can say that x prime is equal to some 2k over y value. So then, no matter what, where k is equal to the y, or I'm sorry, is equal to your y equals line. Y equals some value. And that's your generic case for this slope, or this projection. So to get any projection from x equals 2 onto any perpendicular line, x equals 8 or y equals 8, x prime will be your new x prime value on your y equals 8 line will be influenced by this y value on the x equals 2 line, but now you're going to have 16 over y. And that is projection of x equals 2 onto any y equals perpendicular line.